But there is a twist. Let's understand that twist with the following sum. 50000 minus 34090. So let's apply the sutra here. So we first put minus 1 below the first bottom line, and we replace next 3 zeros of the top line with 9s, and we replace the last 0 of the top line with a 10. Correct? No, it's wrong. Here the last individual subtraction we have considered as the last is 0 minus 0. But this is a simple subtraction. It's not a complex subtraction. So our last one will be the one where we will actually have a complex subtraction. In this case, it is the second last from the left, that is 0 minus 9. So we will consider this as the last, not the last 0 minus 0. But look at the other individual one, 0 minus 0, that is third from the left. Should we consider that as a simple subtraction? No, because there are complex subtractions 0 minus 4 and 0 minus 9 respectively before and after it. So we should not make mistakes in defining the last. So here we apply the sutra correctly and write the answer. So we keep this minus 1 and we replace the next 2 zeros with 9s. Then we replace the third 0 with a 10, and we don't do anything with the last 2 zeros. And now we do the sum, that is 5 minus 3 minus 1 is 1, 9 minus 4 is 5, 9 minus 0 is 9, 10 minus 9 is 1, and 0 minus 0 is 0. So now we can easily solve complex subtractions using Nikhilam Sutra, which look like a particular type. That is, in the top line we get one digit from 1 to 9 in the beginning and a series of zeros after that, and in the bottom line we get any number which is obviously less than the top line number. Though we would love to solve this kind of complex subtractions as we have learned it now, we do not get this particular type of subtractions most of the time. Though we can solve any complex subtraction using the existing Nikhilam Sutra directly, but we can use a much easier method. So life is not simple, but we can make it simple if we know the tricks that can make it so. So as I told earlier, the best way to handle complex subtractions is to convert it into a simple sum using some kind of formula. Now let me give you the new method by which you can convert any complex subtraction to a simple one. Let's first do the unsolved complex subtraction that I have mentioned in the beginning, that is 45678 minus 36789. So our objective is simple. We will start from left, and whenever we get a simple individual subtraction, that means the top number is bigger than the bottom number, we will simply do that. Like in the first case, we have 4 minus 3, it's a simple subtraction, so we do the simple subtraction, that is 1. And whenever we get a complex individual subtraction, that means the top number is smaller than the bottom number, we will give it a 0 first, then we'll do a reverse subtraction, that is deducting the smaller number from the bigger number. That is how we love it. So fortunately, our next individual subtraction, 5 minus 6, falls under complex subtraction. So we first give it a 0 for being a complex one and do a reverse subtraction, that is 6 minus 5 instead of 5 minus 6, to make things simple, like this, 0 and 1. And we are quite fortunate today because all the balanced individual subtractions are complex ones. So have we started to love complex subtractions too? So let's make them simple first. So 6 minus 7 is again complex, so 0 and 1. 7 minus 8 is again complex, so 0 and 1. And 8 minus 9 is again complex, so 0 and 1. Now forget the top two lines, our original subtraction, forget it, and concentrate on the lower two lines, which says 1 0 0 0 0 minus 1 1 1 1. Wow! Can we not use the three-step Nikhilum Sutra to solve it now? Yes. So let's do it. So we put a minus 1 below the first one, and then we replace the next three zeros on the top line with the 9s, and the last 0 we replace it with 10. Now we make it 9 minus 1 is 8, 9 minus 1 is 8, 9 minus 1 is 8, and 10 minus 1 is 9. That's it. 8889 is the answer of the complex subtraction 45678 minus 36789. Isn't it simple? Let's do another one. This time let's handle a more complex one. So the sum is 4645053219310 minus 3756036890424. Oh, what a complex subtraction, but we love it now, so don't worry. So let's first divide this complex subtractions into different parts. So it has become 4 minus 3 is 1, 6 minus 7 complex 0 1, 4 minus 5 complex 0 1, 5 minus 6 complex 0 1, 0 minus 0 is simple, so 0 0, 5 minus 3 is simple, so 2, 3 minus 6 complex 0 3, 2 minus 8 complex 0 6, 1 minus 9 complex is 0 8, 9 minus 0 is simple, so 9, 3 minus 4 is complex, so 0 1, 1 minus 2 is complex, so 0 1, and 0 minus 4 is complex, so 0 and 4. So let's forget the top two lines and concentrate on the bottom two lines of our new subtraction. So 1 0 0 0 0, 2 0 0 0, 9 0 0 0. This is our top line, and the bottom line is 1 1 1 0 0 3 6 8 0 1 1 4. So we now have to visually bifurcate this new sum in such a fashion so that we can apply the three-step Nikhilum Sutra easily. So it has got a three easy looking subtractions now, so we can do it now, right? So let's do it. So we replace the zeros with 9 and minus 1 9, last one 10, again minus 1 9s, and last from 10. So the final answer is 889016328886. So with a little practice we can do huge complex subtractions in seconds using this new method. If we practice more, we can write the final answer directly by calculating the rest of the processes mentally. Maybe at a later time we can answer verbally. So with this new method, we do not need to worry about the borrowings and other complexities of subtractions. We have learned how to convert a complex subtraction into a simple one. Now we love subtractions, right? Don't we? It would be great if you put this new method in practice. I don't think you can write in this fashion in your exam paper now, because you may not get proper marks if you do so. But you can use this method while doing your rough work. Get the answer from there and write the answer in the answer sheet. Maybe it's a naughty idea, but you may continue doing in this way till your teacher or school accepts this method. It's unfortunate that Vedic mathematics is not yet accepted as an official method of solving sums, even in India, but we can hope for the best. Thank you for watching this video. This is Subhendu Sen.